7.6 Properties of the Equilibrium Constant. Just like I have here, having colored writing tools or highlighters would be extremely helpful for this section. Okay, so equilibrium property stuff. You can use other reactions K values, so other equilibrium constants, in order to get the equilibrium constant of a reaction. This is kind of similar to Hess's law, which was back in section 6.9. Kind of. There's some slight different rules, but in general, it's like pretty similar, where you manipulate the equation and then do stuff to it. Now, again, as a reminder, we're only doing solutions for Kc or gases for Kp. Unless the gases are given in concentration, then we can use Kc. Again, Keq is the generic way of writing it, and these are like slightly more specific equilibrium constants. So, if we're multiplying reactions, we're going to power that K value. So what do I mean by that? So you can see here that if I multiply a reaction, I'm going to raise the K to that power, whatever I multiplied by. I'm going to call it K nu. You can call it K2 or whatever you want to call it. So I have my example here. Oh, before the example, if we think about the coefficient and putting it here, and then I think about what I'm doing in the KEQ part, you're essentially, making this higher and this higher, the superscripts for the K value. And so that's why we're raising to the power of whatever you're doing to the reaction. So here's an example where I have this one. And so if I needed to manipulate this reaction by multiplying it by 2, my K nu is going to be squared. And so I'm taking that whole CO and O2 half that was from the original problem, and I'm squaring that. So if I had the value, so here is the value at 4.6 times 10 to the 23, I am going to power it to the 2, and then I get my answer. So that's where the values are coming from. Again, it could just be the equilibrium reaction, or it could be the answer. So be very careful about that. Again, I'm calling this K nu. You can call this whatever you want. K prime, K nu, like it doesn't matter. Cool. Okay, if I reverse reactions, so instead of going from reactions to products, it's products to reactants, I take the reciprocal of K. And so we're inversing, in case you don't remember what reciprocal is. And so again, we're switching reactants and products. So reactants become products become reactants, And so here is my example formula. And so I'm going to write my K real quick. So here it is. If you notice, I don't have water there. Why? Because it's a liquid. That's why. So you want to be very careful about this. We have our solutions, we have liquid, so I'm not going to include it. I have my products over my reactants, and then I'm giving you the K value for this, right? Just so we can use it as an example. And so if I'm reversing it, so I'm taking this whole thing and I'm flipping it, and so now I have the new products and new reactants. I'm going to take that K and do the reciprocal. So inverse, in case you don't know what reciprocal is. And so 1 divided by 1.8 times 10 to the negative 4, this is where the value comes from, and then I get that. So if I'm flipping the reaction, I'm doing the inverse of the K value. So that's different from Hess's law. That's why I said similar-ish. Cool. And so if I add reactions together, I'm going to multiply those Ks. So you multiply the original K values, okay? And so here is my reaction. Here's what's given to me. As a quick mini your turn, go ahead and write the K values for each of these reactions real quick. Okay, and so for the first one, we only have aqueous, no solid. That's why there's no solid on the bottom. And then for the second one, cool. So products over reactants. Beautiful. And so I have that up here just as a reference. Okay. And so if I were to add these, I'm pretty much going to multiply these together. So I'm going to show both the numbers as well as these canceling out and such. So this is from the first equation, and then these two are from the second one. And so I'm going to cancel stuff out, so I can see I have an AG plus and AG plus here, so that cancels out, and so I'm left with that at the end. And so we might need to solve something with this, which is why I wrote it down. And then, like I said, the k values multiply, so k1 times k2, and then I get my k net. Remember, net usually is meaning combining stuff. Usually students think it's only addition, but technically I'm combining two reactions together, and so that's why this is called k net. But again, you could call it whatever you want. It doesn't really matter. You could call it k nu also. Cool. And if I'm dividing reactions, I'm going to root k. So when I was multiplying reactions, I did powering, and so the opposite of powering is rooting. And so here is this reaction once again with the k values here. And so if I divide the reaction above by 2, so I have fractions, and so I take the k value and then I do fractions. Hooray. Now I am rooting by 2. If I was dividing by 3, then I would root 3 it. If I was dividing by 4, I'd root 4 it, and so on. Oh, I forgot the half here. Oh well, don't forget the half there. And so I would square root this. I get an answer. I can write it both, the long way or the sine knot way. So, whatever. Now, remember, k values are not related to sig figs, really. It's a constant based off this reaction, so don't worry about it for calculation purposes. Cool. And so the last tiny bit of this is, honestly, if you're doing Q, it's the same rules. So it doesn't matter if it's K, doesn't matter if it's Q, because remember, Q is just the reaction quotient, and it's still products over reactants. It's still the same thing, manipulating Ks and Qs. Cool. So here's your turn. Pause the video. Try it yourself. It's on your paper. Cool. And I even give you the answer here. All right, ready? Here we go. So the first equation, I'm going to reverse it. So I'm going to inverse the k. Second equation, I'm going to reverse it and also multiply it. So you're inversing it and you're squaring the k value. And then the third one, I'm multiplying by 4, so I'm going to put this to the 4th power, because multiplication of a reaction is powering it. Then I add these up based off doing these manipulations to make sure that I got the overall. And so here are my manipulations of everything. And so I'm going to add these up, and when I add up the reactions, that means I'm going to multiply all those k's together. Now, I forgot to do that on the slide. So make sure that you add these up, check does it match the overall, do the math for these where it's 1 divided by that squared, and so on and so forth. And then whatever those answers are for K1, K2, K3, multiply them together. Okay, that's it. Bye.